Good morning, everybody. Hope you can hear me okay. My name's Lloyd. I'm the Director of Advisory at the Open Data Institute. Thank you all for coming along today. I'm going to be your MC for the day and try and keep everybody to time, keep things moving. So that's my job. To formally open the event, I wanted to introduce Professor Richard Clegg from the Lloyd's Register Foundation.
Hello, everybody. Well, it's really impressive, stood up here with so many people in the audience. I've got 5 minutes, really, just to open this up a little bit and to put a bit of background to why, as the Lloyd's Register Foundation, we're interested in this subject area of engineering data for public good, and this is what today is all about. And actually, we don't see this as just a day's event. What we're really hoping that we can start to achieve is to create a global movement, the beginning of something around how to open up and share for the benefit of society, with the economic benefits, the safety benefits, the social benefits of opening up engineering data. Out of today, what we would really like to try and achieve is to create a manifesto behind this whole doctrine of engineering open data. Where are the benefits from this? Why would anybody want to do it? And if we wanted to get there, what are the barriers en route? So how would we start to unlock all of this? And why, as a foundation, as the Lloyd's Register Foundation, are we interested in this? And actually, it all goes back to this document here. It's one of our foresight reviews. It's on big data. It surprises me how quickly time bloody goes by, because this was 2014. Nigel Shadbolt chaired the group that the international panel that produced this report for us. And one of the great things is that this document did not just sit on a shelf and collect dust. And on the back of this, we became the first investor in the Alan Turing Institute and gave birth to this whole discipline area of data-centric engineering. And Mark Girolami, who heads that program for us at Turing, is speaking later. And we put around about £10 million as a foundation into data-centric engineering. Another thing that this also said all those years ago is to begin to think about codes and standards, opening up data, assuring data qualities, and getting the social, economic, and safety benefits from the cross-sharing of data. And as I say, you can get this from our website, and you can get it in all good bookshops and on Amazon. You can't actually, I just made that up, but it is available on our website. So what we're trying to do today is to create this global movement. I really hope that we'll look back and say this whole area of data sharing, engineering data for public good, where did it begin, where did it came from? And I hope that we'll look back and say it all started in this room today with us here. So we've got a cross-section of people from data managers, people from engineers, industry people, and policy professionals, etc. And I really hope we have a fruitful day, and that it leads to things afterwards. And if you want to get involved in this movement, then speak to the ODI or to myself, of course. Just have a really fantastic, fruitful day. Thanks.
Thank you, Richard. So we've organised today to be a kind of mixture of talks, panels, some short lightning talks. We're having some roundtables this afternoon. To give a bit more detail on the project and what we hope to achieve today, I want to introduce Dr. Jeni Tennison, who's the CEO of the ODI.
Thank you. That's me. Hello, everybody. Nice to see you here, and thank you so much for coming. Thank you for waving at the back there. That's very encouraging. So we're here as the Open Data Institute hosting today, and that's because we at the Open Data Institute try to get the best out of everybody's data. We think that the value of data comes from it having an impact in the world, the way that it affects the decisions that we make as individuals, as businesses, as policymakers and planners, as communities. And it's really important to hold that in our minds, because we often, certainly myself, as a data geek, get very excited about data itself and not really think about what it takes to really ensure that data makes an impact, a difference in the world that we live in. When data has a real value, it's because the variety of people that make decisions off the back of it is very broad, from different kinds of communities, different kinds of organizations. And to get to that, then you need to have support from organizations that create applications, products, services, analyses, insights from data. In our very, very basic, very simple data value chain, then those are the creators in the middle, that second circle there. It's them that really serve the people who make decisions off the back of data. But for them to get hold of data and do something with it, then we need good stewardship of data from data stewards that then can collect, maintain, and share data. So this is our very simple way of seeing the kind of steps that are involved in getting data to have an impact in the world. And of course, sharing data is a really important part of that. We see two threats to a world where data is really having a strong impact, a good impact in the world. One is that we have organizations holding on to and hoarding data because they think that they are the best people to get value out of it, or they want to prevent further value being taken by other people. And in that kind of data hoarding environment, then you get only very narrow decision-making being able to be made. Only those that have access to the data can use it, and it's a very narrow consumer base that looks like. So we work at the Open Data Institute to try to get more openness, more sharing, so that more data can go to more people to make more decisions and therefore have more impact. The other future that we worry about at ODI is one where we get so worried about the kind of negative impacts that data can have, particularly on us as people, and the impacts on our privacy, that we start to shut down or fall back from collecting and using data that is about individuals. So we call this a data-fearing future, a wasteland where less data is collected and used, or people start to mislead or lie when they provide data because they're worried about the impact that it might have on them. So those are the two futures that we worry about. We think that there's a very strong and good impact that we can have from data, but we need to navigate between these two futures, between too much data hoarding and too much data fearing, to a future where data really works for everyone. So this gathering is part of a project that we're doing with the Lloyd's Register Foundation to encourage this movement that is focused on creating a resilient, safer, and more innovative future where data works for everyone, specifically in the engineering domain. And we're doing that through a combination of research, through events, through talking to people and understanding really what the barriers are that are stopping data from being shared more widely and getting those benefits that we see. So today we really want to learn, we want to share insights from your experience working with data in engineering. We've arranged it so that there's lots of chance to talk to each other, to make connections with each other, to network and make friends. And what we hope is that this can contribute towards the beginning of a more global movement around the sharing of engineering data. This is the agenda for the day, so that you know where you're supposed to be at what times. You've got it on pages in front of you on the tables as well. So I'm going to chair a panel in a second. Then we're going to have some lightning talks highlighting some particular projects. We'll have a bit of a break, then another panel, a longer lunchtime, another panel on enabling change with technology, research and regulation. And then we're going to be discussing everybody in groups on our tables, the kind of barriers and visions and technologies that can lead us towards this future that we want to see. Plenty of chance for networking, and then Lee's going to wrap up at the end with the insights that we've got from the day. So what we really want from you, this needs to be a two-way conversation, not just lots of projection at you. So there'll be plenty of chance for you to ask questions as we have our panel sessions and so forth. We really want you to share thoughts and experiences during the roundtable sessions later on. We want there to be some excitement around the event on Twitter and online as well, so please do tweet. There's the hashtag is data for safety there. And we've also got Slido, so we're using Slido as a way of gathering thoughts from you. So if you go to sli.do, Slido, and you enter hashtag data for safety, then you'll see a questionnaire there just getting your ideas around sharing data for engineering. And there's also a survey to understand what you see as the barriers for doing that. And we'll be changing that through the day. So if you are online or can get online, then please do fill in that survey. Okay, so now we're going to go into the first panel session, and I'd like to invite my panelists to the stage. So we've got Dr. Helen Barnforth from the Health and Safety Executive, Nigel Shadbolt from the Open Data Institute, Mark Enzer from the Digital Framework Task Group, and Professor Jim Norton from the Royal Academy of Engineering to join me on stage. Right. So this first panel, what we really want to dig into is what this vision for engineering data really looks like. So I'm just going to ask the panel to introduce themselves, tell us a bit about you and where you're from and what you're up to, and then give us a kind of vision for what is it that you see as being the future for engineering data. Shall I start with you, Mark?
Right, okay. So good morning. I'm Mark Enzer. I'm the Chief Technical Officer at Mott MacDonald, but I think the more relevant thing for being up here just now is that I'm the Chair of the Digital Framework Task Group, which is a bit of a mouthful to say, but that was established following the recommendations from the National Infrastructure Commission about us moving towards having a national digital twin and needing to have an information management framework to enable that, and then needing to bring together academia and industry and government in order to facilitate that. So that's what we've been doing since July last year. Hopefully you might have seen the Gemini principles, which is one of the first bits of output from that group. The idea of that is to help produce a bit of a seed crystal around which we can start to form consensus on the way forward towards this national digital twin, which is really based on secure, resilient data sharing. So totally what we're talking about just now. So I think maybe that's enough for me to say as an introduction. There's a whole load more that I'd like to say, but I think maybe that will come out in the conversation.
Cool. Jim?
Yes, good morning, everyone. I've spent, I'm almost embarrassed to say, almost 50 years in the ICT industries, 25 of them at board level in the public sector, in the private sector, in the charitable sector, and as a regulator. Past president of BCS, the Chartered Institute for IT, and also a fellow of this academy, and for relevant to today, I chair the Academy's Community of Practice in Digital Systems, where we've, for the last 3 years, had a particular focus on data sharing. So we published the report Connecting Data back in 2015, November 2015, and followed that up with a report on, interactive report on data sharing initiatives in December of last year. In the meantime, done a number of smaller things. So the whole agenda which Richard outlined is absolutely key to what we see as important from the Royal Academy of Engineering. And Philippa Westbury, who's done most of that work with us, is chairing a session this afternoon. Thank you.
Yes, Nigel Shabolt. I'm a professor of computer science at Oxford University, but also was a co-founder, along with Tim Berners-Lee, of the Open Data Institute. Over the many years, actually, I'm delighted to say less decades than Jim, so not often I get to say that nowadays. Kind of pushing this idea of how data can be, in a sense, a transformative part of our societies. As Richard referred to, working over the last couple of decades, I suppose, promoting the idea of everything from the semantic web, the web as a distributed repository of data sets, often isolated, but how can we find and discover them, opening up that data where possible, and most recently, really concerned about the issue of the quality, but also the purposes. So various academy roles. One of them recently with the Royal Society next door, of which I'm a fellow as well as this one, was to look at the notion of human augmentation. So can data oppress or empower us? And actually that's also a lot of the flavor of what we're going to discuss here. I mean, much of what we do is value driven, as I think it should be. But then there's the engineering question. I mean, what do we mean by data as infrastructure? How do we engineer our data to be reliable, reproducible, efficient, scalable, transparent, secure, and a whole set of other desirable characteristics when in fact much of it is crap, okay? And shockingly so, in a way that makes us want to pay attention to issues around safety, and I'm sure these issues will come out in the course of the day.
Okay, thank you. Hello, everybody. I'm Helen Barnforth. I'm the head of data analytics at the Health and Safety Executive, and I'm also the program director for a Lloyd's Register Foundation-funded program, Discovering Safety. So the Discovering Safety program is about making global health and safety improvements in performance. We want to use data and analytical techniques to provide new insight to do that. So I think for me, my vision is being able to really break through the plateau in health and safety performance improvement that we've seen recently, using data to do that, new insight to do that, thinking about things in different ways, but then also being able to accelerate improvements in health and safety, using the lessons that we can learn and sharing data together to do that. So it's really about that sharing piece and having data at the heart of that. So very much looking forward to the discussions that we're going to have today.
Thank you, everyone. So to dig into this kind of vision for what the future might look like, how would we experience the world differently in a future where data is being shared and used more widely? What would we see as being the impact on engineering professionals, on the kind of people that are in the room at the moment? Mark, would you pick up on some of that?
Yes, I mean, I think in many ways it's easy to say and difficult to do, but one phrase that I think encapsulates it for me is about putting the right information in the right hands at the right time to make the right decision. A very, very easy thing to say, yeah. But if we could get that to happen, then it would be transformatory. So I think that's one part of it. And I think also, if I could just pick up on the national digital twin piece, because I feel that that's a key part of the vision. What that's about is really connecting digital twins. So I guess everyone in the room is familiar with the concept of digital twins, just kind of looking for nods or shakes. I mean, in essence, it's about having a digital representation of something that's physical. And so in the built environment, we would be talking about having digital twins of assets, processes, and systems that would help to facilitate better decisions and therefore better interventions leading to better outcomes. And so a key thing about a digital twin is having this two-way flow, data going one way and interventions going the other, and interventions based on better insights and better decisions. So that's an individual digital twin. but how much better it would be to join the twins together. And so you could easily imagine, for example, a digital twin used within an individual water company, and that helps them to manage their assets better. But then there's a water company right next to it, and why not have data sharing between those water companies that enables better interface between them? But then if we can imagine that, and so now we're maybe thinking about a digital twin for the whole water sector, then why wouldn't we also have that kind of data sharing between the water sector digital twin and the energy sector digital twin? And so you can see that there's this kind of idea of federation and ever greater value being released, but it has to be facilitated on secure, resilient data sharing between organizations. And so when we talk about a national digital twin, it's definitely not one massive twin of everything. It's much more about a connected ecosystem of twins. But you can almost instantly start to see the value that would give us. However, it has to be built on the hard work of enabling that secure, resilient data sharing. And that doesn't come without getting our act in order, getting our house in order, on some of the kind of the boring, geeky stuff to do with the data in the background. So that would be my vision, really. It's the information piece, right information, right hands, right time to make the right decision, but also this bigger, grander vision of what data sharing could give us across the whole built environment.
And the examples that you were giving there were picking out decision-making by the operators of these systems as well as the people planning and designing these systems. Have I got that right?
Very much so, very much so. Because I think that within the construction industry, there's been a focus on building new assets. But the thing is, we've been doing that for 200 years now, and we've been connecting them up. So now what we have is this amazingly interconnected system of systems that is our economic and social infrastructure, but we don't model it very well. And so, yes, definitely talking not just about the delivery of new assets, but also the operation, maintenance, and crucially the use. It's the whole asset life cycle of the whole system of systems. All of that gets unlocked if we can sort out this issue of data sharing.
Okay. Helen, could you pick up a bit on this? So from a kind of health and safety perspective, what kind of benefits do we see and why do we see them? How does sharing data help with that?
Yeah, okay, so I think for me there's two things. I think to start with, having access to a data-driven approach allows us to actually have data from all parts of the system, so we can really start to understand the safety landscape. So, for example, we could collect data from plant and machinery. We could collect data from the processes that are happening. We can collect data from the workplace location. We can understand the procedures and understand how they're being used, but also importantly, we can collect information from the people, so we get that holistic picture, and it's joining up that will actually give us that safety landscape. And now we're in a better position to be able to do that, so we can gather information in different ways. We can have automated sensing, we can have wearable technology, for example. It's allowing us to do this in many different ways that aren't quite so intrusive or so burdensome as previously. And I think having that understanding of the current safety landscape would be a big step forward. But then obviously the next step is to then take that, use the data to help actually deliver new solutions that can help reduce harm and basically improve well-being. And I think for me, that's the vision that I'm looking for.
Yeah, thank you. Jim, Nigel, was there anything you wanted to pick up on in those?
No, I think we'll get into some of the kind of detail of how we realise that. I would just say that we're going to hear great examples here. I mean, people here are committed to architecting a data ecosystem which is better, more efficient. It will have to recognise some brute facts, which is that not everybody is going to declare all of their data open, and neither would it be desirable to. It's going to recognise the fact that it will intrude across personal and public data interests, private and public, regulatory and areas which are not yet under a regulatory framework. We are struggling with the fact that we're constantly in a state of transition, but in this one in particular, in the world that's unfolding in the 21st century with AI, digital twins, digital assets, we have a sense that there need to be new settlements, new organizational, socio-technical structures on the one hand, and there's a bunch of engineering to do But engineering's always been about that balance between broader societal interests and new forms of institution. I mean, the engineering community par excellence has been very creative about thinking about the new institutions it might need to represent the interests across sectors. And I think we'll be talking about this balance through the day. We've got some great examples. We'll hear about them later, things like HiLo and so on. So we'll hear about this. Yep.
Yeah.
Just very quickly, I think if we can actually implement the vision that you and Richard have explained so well, it would make our practice of engineering vastly more satisfying and vastly more productive. And I think that's a key goal. At the moment, we have vast amounts of data. Most of it we simply throw away. Much of the rest of it is useless because it isn't properly structured, it doesn't have proper metadata. There's a huge amount we can do here as practicing engineers to realize that vision.
So one thing that I view as a real advantage working at ODI is that we work across lots of different sectors. So we work on health, we work on, in transport and so forth. Do you have any feeling about the way in which engineering kind of relates to those sectors, or is engineering ahead, behind? What are the particular challenges that engineering has as relates to maybe compared
Well,
to...
let me give you one example. I mean, health is always, I mean, it's very hard to see where engineering stops and starts. Its interests are extraordinarily broad, and it's no accident that within this institution and many people here, that there will be health-related concerns directly. I mean, and look at what is happening actually within the health service at the moment may be one of those moments when there's a genuine opportunity to do something quite innovative around the engineering of health. But once you get into the mundane prosaics of all of this extraordinary data, which we know if it were connected at scale would do some remarkable things to diagnostic accuracy, to efficiency savings within the NHS, when you look at the detail, you will often bruise your toe, as Jim said, on just facts that the data is badly curated, there is no systematic set of standards, that the number of local dialects in ways this stuff is represented, stored and curated is just kind of like, it's a Babel, you know. And stuff isn't collected and maintained within an incentivization cycle that means it's worth anybody's while to curate for the future, despite all of the grand plans and promises. So there's something really quite fundamental in all of these sectors about realigning some of our incentives to support this.
Jim, you were nodding along. Did you say?
Yeah, there's an enormous amount of really rather boring work that needs to be done here. And I've described as fixing the foundations. The legal structures in the UK don't really accommodate what we're trying to do. I know the Law Society is working on that. The accounting structures don't facilitate what we're trying to do. We don't value data. It's an interesting challenge as to how you do that, but it's one that we need to address. What I know the government is addressing for public sector data. We haven't really got competition law set up quite right in this area. So there's a huge amount of work we need to do to facilitate this process. And it's a multidisciplinary work with multiple other bodies that we need to bring together and commend the ODI on that.
Thank you. Helen, would you add anything? How do you see engineering data sitting with other kinds of data?
So I very much agree with the fact that we've got a very complex picture at the moment. That's probably putting it quite politely. But I think what I suppose the vision that I've got and the opportunities that I see is that we can actually start to do things differently. So we can design things in, we can start to collect the information that we actually think we're going to need to make the decisions that we need. So we can start to sort of engineer that in. We can collect the data. We can then feed that through to the decision-making process, the regulation and the intervention side of it. So actually you could imagine a system where you have data coming through, the right sort of data, perhaps looking at leading indicators data rather than lagging indicators data, so we get an idea of what we can do before things have happened, before dangerous occurrences have happened. And that system is automated, it comes through to regulators, we can see data, so we have less actual intervention that's not needed by using the data-driven approach. We're intervening where we need to, so you could have, if things are all coming up as green, or your sensors are saying your leading indicators are green, you don't need our attention. Right. And that's the sort of future that I'd be looking for with this approach. So I think there's lots and lots of opportunity, but loads of hard work getting that sorted,
So I think we're united on this view that there's loads of hard work that needs to be done in the background. And I think that would be true within individual organisations, but I also think that we need to have something in common held at a level that's high enough that means that we can then all join in the same game. Because I think there is a danger that each organisation goes away and tries to put its own house in order, but does it in a different way to the organisation next door. And what that effectively would do is set up lots of different ontological islands, which would then mean that we would build in almost forever a big overhead, a kind of a translation cost from one to the other. And so it kind of makes sense to have something at a high level that informs what happens at a lower level, not in an officious authoritarian way, but just unlocking value so that we can have the secure data sharing that we all desire. But it seems like we need to hold something in common at a high level that does this unlocking at a lower level. And I think that we need to be doing the work to work out what goes in that commons. My personal view is that it should be the minimum necessary to unlock what's needed lower down, not the maximum possible, the minimum necessary. But it does seem like we need those higher level rules to set out the game, and then everyone can play the game, without too much intervention, but also without too little.
I'm going to be coming to questions very shortly, so start thinking of any question from the audience. So start thinking of any questions that you have. Just picking up on that point. So you're talking about there being some kind of commons, some kind of bringing together of the sector. How do you see, and for each of you, how do you see different institutions, different organisations having a role in doing that? Who should be doing what? What would you like to see happen?
Well, I mean, I think we will. So Richard talked earlier on about about a manifesto, okay, and professional societies will have a role.
Right.
Existing forms of regulator. It's interesting that if you take the Lloyd example, kind of both poacher and gamekeeper in the nicest possible sense, that they become hugely respected and trusted as an arbiter of certain level of standards in a field. Now, the question is, will those organizations expand into this role with support from others around it? Will new forms of relationship need to be developed and informed, new kind of players in the market? The thing that will grab people's attention, I'm just come back to this, what will motivate people to make a change? Because I think there'll be quite a lot of violent agreement around what we would like to see.
Yeah.
The disagree, I think the thing where we would really generate some interesting creative abrasion here is to say, how do we do it, okay? Where is the fear, greed, and distress that will get people to change? Common purpose is a great thing. Corporations with a purpose is a great thing. The public good is a great thing. But when people are being litigated against because there is some intrinsic bias in the underlying representational distribution of their data, as will happen with some decision-making comes through, people start to think, could I have been assured that that was a better data set? Did I collect it in the right way? And I think that's something we need to think about, is where will the pointy stick be, and where will be the carrots, the incentives that we can line up to say, you would not want to be in this place, would you?
Can I take that more broadly? I think we need to carry our general public with us and explain why this matters, because there will be big productivity gains from it, why some people will be put out of work by it in things like machine learning, and more importantly, what we're going to do for those people. So, for example, there are models out there. If you take Sweden as an example, there is a levy on employers which is spent through trade unions to retrain people who are thrown out of work by new technologies. Brilliant idea. The result is there's a very low lag of people being unemployed in the Scandinavian countries as a result of that. But we need to explain what we're doing. We need to build on, again, what the Royal Society did earlier this year and last year, their AI&U program, trying to explain exactly what's happening here, the good bits, the challenges, what's going to be done about the challenges. But what we can't do is proceed in isolation and assume everybody will think it's a great idea. Yeah.
Helen, was there anything you wanted to pick up on?
I do think we sort of need an interdisciplinary approach.
Yeah.
I think we don't want to create more silos. We don't want to create a sort of something that's forced upon people. Society needs to buy into this new approach and what we can do with data, absolutely. So I think for me, we need to do that. And I think a big part of that is actually demonstrating what we can do with it, the impact that we can have, the difference we can make, and people will feel more engaged, more likely to sort of get involved with it. But also there's a big piece around trust. People need to know that this is going to be used in the right way. It's going to help improve their lives. So from a health and safety executive point of view, we could be reaching parts of the workforce that are very, very hard for us to reach. If we can think about, for example, more personalised health and safety, you know, it's totally different approaches that we can actually now start to think about with data.
Yeah, I agree with that. And I think that whereas I totally recognise that the built environment is just a subset of engineering, lots of different types of engineering going on. But I think if we were to try and answer that question of, you know, how do we do this thing?
Yeah.
Within the built environment, because of the leadership coming from the National Infrastructure Commission, because of the recommendations in that report, Data for Public Good, it means that things are coming together in the built environment. And that the way that that's going, I think, is very much in line with what you've said. And it's much more about coordination and alignment. It's definitely not about control, because that doesn't work. But I think with the Centre for Digital Britain at Cambridge University kind of being anointed as the owners of the vision for Digital Built Britain, that's really useful to have a centre. And they see their role as being to helpfully align others so that we all go in the same direction. And so, for example, within the context of the Digital Framework Task Group, and we must do something about that name, we have the Geospatial Commission is involved. You know, the Geospatial Commission itself has a massive role to play in this. You think about all of what could be done to do with geospatial data, and you know, that's part of the built environment. But also the ODI is involved, also the Centre for Protection of National Infrastructure, also the ONS, also the Alan Turing Institute. You know, so we tried to pick off all of the big players who have got their fingers in the information pie, and the idea, like I said, is to provide alignment so that we can move on the journey together and learn as we go, rather than have somebody say, I know all the answers, and impose it on the industry, because obviously that wouldn't work. And so one of the really positive things I think that we're starting to do with CDB is form something that we've called the DT Hub. It's the Digital Twin Hub. And that becomes a kind of a collaborative, safe environment where those who are developing digital twins can come and learn and share, hopefully to copy each other's homework so they don't fall down the same hole. But also within that context, we can start to see what works and spot the best practice and grab it, you know, and share it. And then out of that can come guidance, and out of that can come standards. So we kind of grow it from the bottom up, but in a guided, aligned, helpful kind of way, rather than an imposition or a kind of an authoritarian, we've written the standards, you have to use the standards kind of way. So I'm very much in favour of this kind of approach of alignment and bringing us all on the same journey, because I do think we're starting to see the same goal, and therefore we can move in the same direction.
Thank you. Right, I would like to turn to the audience now. So any questions, comments, violent disagreements? Anybody in the audience? I see a hand there from Ruth.
Thank you. Ruth Bumfrey from the Lloyd's Register Foundation. Can the panel comment about the concept of setting out a grand challenge in this area? So when the example that I have in my head is from the weather forecast, when the problem of weather forecasting is a problem of sharing data, and society set a challenge, 30 years ago to say, let's go from a one-day weather forecast to a 4-day weather forecast. And that's had huge societal, economic, safety benefits right across the world. And I wonder if sharing engineering data, number one, would you agree that the setting a challenge help, a grand challenge help? And number two, if we did set such a challenge, have you got any ideas what that challenge would be?
Fantastic question. So, Helen, do you want to go first?
Thank you. Well, in many ways, Ruth, I think the programmes that you're sponsoring are setting some of those challenges for us. So, Discovering Safety, for example, we've got a challenge to improve global health and safety performance. That's, you know, as big as you can get. But we're actually going to be testing some of the ways that we can do that. And I think showing people what we can do gathers the momentum and helps to buy in, you know, the engagement that we need. And I actually think the Lloyd's programmes actually have a lot of synergies. So the Assuring Autonomy, the data-centric engineering programmes, the ODI work, and I think together we've actually got a very sort of good position to be able to demonstrate to national and international audiences what we're doing. And I think that's responding to that grand challenge already. I'm not sure that I can think of another grand challenge that would necessarily sort of work.
I mean, a grand challenge the grand challenge is stopping ourselves going extinct. I mean, that's a fairly good grand challenge. And you're hearing all of this, a real mobilization across society around the notion of moving faster around environmental degradation. And so we know that within the built environment, there are all sorts of challenges. They're being addressed individually and sometimes collectively. And we know that there are some great data sets, both curated, both open, sometimes more collected at a crowdsourced level. But what if we were to isolate one or two lead indicators there and say, off the back of our built environment data, we would locate 5% or 10% emission savings, or all the work that was been done on insulation. You know, we claim and know that we're getting better and more accurate models of just what the consequences of our energy-intensive society is. Well, you know, let's move to a much stronger data-driven determination of those impacts and those opportunities. And we know that literally the exhaust data we generate at scale, small differences, small improvements make big quantifiable, whether it's your meat-free Monday in your kind of favorite organization or whatever it is, that there is a way of instrumenting our environment at the data level which can deliver on big promises. And I think our built environment, its impact on our energy, our impact on the, and that's one. I mean, it just happens to be one for which there is literally a huge appetite at the moment. And the digital twin, I mean, so many elements of that relate to efficiency of transport, efficiency of power, efficiency of built structures. Yeah.
Thank you. Jim? Yeah.
I'd argue we already have it. I think that the access to data, appropriate data, is the meta grand challenge that underpins all the other grand challenges we have. And we need the alignment of those grand challenges, which Mark said very eloquently. We've also got to stop shooting ourselves in the foot. You mentioned weather forecasting. Other people in this room may or may not know that at the moment the work on 5G communications in the States is like to wipe out the water sensing data from the Earth resources satellites. No, this is not very clever if you want better weather forecasting.
So I completely agree with what Jim just said about the the underlying challenge. Because maybe there's a danger of having a grand challenge which sounds very exciting up there, but it's based on something really hard down here, and the really hard down here is probably the grand challenge. So I completely agree with Jim on that. But then I think the idea of a national digital twin that actually works, to me, sounds like a pretty big challenge. But there's a danger in that as well. I mean, it sounds like a very attractive challenge as well. But in some ways, it sounds like just a technical one. And I think that we'll be able to solve the technical aspects of it relatively simply. So I think actually the grand challenge related to the National Digital Twin is one about the outcomes. Because I think the whole point of it is to drive better outcomes for people and better outcomes per whole life pound. And when I'm talking about outcomes, I'm meaning social, environmental, and economic outcomes. That's the point of doing this. And so what I think the challenge becomes is a kind of a demonstrable improvement in the performance of infrastructure as a result of a working national digital twin. And that performance in infrastructure has to be seen both in terms of system performance, but also service performance. It's got to feel better to us as users of national infrastructure. It can't just be more efficient, it's got to feel better too. So I think that's the one. It's actually a demonstrable improvement in outcomes for people.
But it's identifying them, isn't it? Which, I think that's great, and I absolutely agree. Data is the foundation element here. But if you take health as an example, we can assemble grand challenges there. I mean, 1 in 2 of us will contract cancer. We know that we detect them too late. We know that proteomics, a whole range of developments, are giving us much more exquisite data on early detection. If we can get these things detected, the 4 big killers, stage 1 and stage 2, that transforms our landscape. Those are commitments with the technology, with data sharing, that people literally can just get behind. And I just wonder whether we can think of the equivalent in our space. It is the outputs related to digital twin. What would that be concretely? Yeah.
Any other questions or thoughts? So we've got 3 here. We'll take the 3 and then, oh no, we've got much more than 3. I'll take the 3 that I first saw, which were Volker, lady there, and one at the back as well.
You talked briefly about sort of institution building and new ways of sharing or agreeing consensus around sharing. What do you see the role of venture-funded disruption in engineering? So the prop tech industry, according to Forbes, raised 12 billion of highly disruptive money just into property. And the second area where we see lots of change coming is in China right now, where we see much faster progress in large-scale data sharing.
Thank you. Lady just there.
Hello, I'm from UCL. Just to comment that we've been spent 3 years developing an open data platform specifically about collating data on the building stock. And one of our big things is visualizing data. So I was just asking about, was interested in your views on the importance of that, because we found it's absolutely crucial in our work.
Thank you. And then one at the back.
Hi. You talked about quality of data and curation of data and of metadata. In traditional subjects, this has been assisted by some very boring and long-term work done on classifying of subject. In other words, parameterizing subjects. What do you think the parameters needed are to get a better quality of sort of metadata that underlies data collection so they can be better curated?
Right. Thank you. So the 3 questions were, one on the role of venture funding in building institutions, one on the importance of visualizing data, and then one on the kind of parameters that are needed. And sorry if I'm misquoting this around data, around metadata and metadata collection. Do you want to pick off any that you like, Mark? I
liked all of them. Really good questions. I mean, I think on the venture funding thing and the whole idea of driving disruption, I think that the disruption has to be in the right direction. And this thing we were talking about earlier on about the alignment is it's really good to have some positive disruptive forces which point in the direction we want to go. And I guess one of the things I fear are disruptive forces pointing in the opposite direction, particularly if we're working very hard to get the industry to move in the same direction. And the other thing which I kind of picked out of what Volker said there is really to do with the data ethics and the people that we want to work with here, because that issue of trust is absolutely enormous. And you pointed that out, and I love the graphic that you had. The fear side of things, that for the national digital twin to work and deliver its full value, it needs to be trusted. It has to be trusted. And if the people lose trust in the national digital twin, they'll pull it down, even though it's there to benefit them. So I think it's utterly essential that we maintain trust, which to me is something to do with openness and security and quality. All those 3 things are needed. So I'd love to answer the other ones as well, but I need to get off.
Jim.
Okay.
Pick up on any?
I want to quickly touch on that first question as well. I think, first of all, we need to bring China into the international fold here. What we're doing needs to be on a global basis. And being Trumpian, I think, is unhelpful. Also, I think we touch on the need for regulation. And as an ex-regulator, I use regulation very warily. I would like to see voluntary codes of practice, shared voluntary codes of practice. But to make them effective, there needs to be some kind of penalty. So there needs to be some kind of enforcement. In the past, government's been very good at setting up voluntary codes of practice, then completely pathetic at enforcing them or responding to them. And I think there are ways of doing that, even if it's, for example, paying the Consumers Association to embarrass people. We need those voluntary codes to work and to build the trust. I've had to touch quickly on one of the others. Data visualization, absolutely key. There's that wonderful quote that I'll get wrong from T.S. Eliot from the 1930s, where is the knowledge we've lost in information? Where is the wisdom we've lost in knowledge? And data visualization is a brilliant way of getting up that hierarchy.
Yeah, I'd agree with that. The final point also was, I think they've all been good observations. I think the notion that China's effective use of sharing of data, there is a big discussion, of course, around the fundamental social values behind that, and will they be our values? Are they ones we want to share? You know, I happen to enjoy the benefits of living in this society, which is born out of a set of principles. Some of them go back to the Enlightenment, you know, self-determination, personal autonomy, dignity of the individual. These are important values, and we should not lose sight of those, to be high-minded about it, but it's absolutely true. I thought the other point was this prosaic point about data curation is really crucial. And I think when I look at what's happening in my own sector, if you like, of higher education research, the products of research grants and public funding, and we are under various mandates to make that data available to a high standard with a research management plan for the data. And in truth, we are really up against the resourcing of that. We haven't understood how to reinvent everything from our library science through our information collecting to our indexing, our cataloging, stuff that actually universities and libraries used to be, and institutions, learner societies were very much the custodians of. And I think we haven't understood how that prosaic work is so fundamentally important to what we do. Yeah.
Trying to persuade another set of friends down the road, the British Association, that the new professions of data curation, data librarian, are actually really important, and they ought to be driving them forward.
Helen.
So I think the visualization point is really key as well, because I think a big part of what we've got to do is about communication. So we've got to articulate that in a way that we need to think differently about how we can engage with as many stakeholders as we can, nationally and internationally. And I think the visualization of our data is going to be absolutely key to that. We need to engage with different parts of the world, different parts of society, and that, I think, will be the key to doing that.
Thank you. Were there points you wanted to pick up on?
Yeah, there were actually, sorry. So just quickly, on the visualization piece, I mean, I see the visualization being an essential part of a digital twin. Because I guess if you break a digital twin down into its essential components, it's got something about taking the data in, something about doing something useful with it, and then something about getting it into a brain of a human. The visualization is the key last stage, in whatever form it might take. And I guess there are just ways which are easier for us to assimilate. And it seems that when we see 3D pictures, that's really, really easy. When we see maps, that's really easy. And so it seems like visualization is an absolutely key part of representing the data, the insight that has been based on the data back to us. On the curation bit, I don't want to open up a whole new thing, but if we do agree that it makes sense to have some kind of commons at a high enough level, at a maybe a national level, that informs what we do below and unlocks the value, then we have to work out what goes in that commons. And I think within the Digital Framework Task Group at the moment, we're doing exactly that, trying to work out what goes in there. But the kind of thing that you might see appearing in there could be a national reference data library, for example. Not a centralized reference data library, but a kind of a federated library, where those who know their reference data best set it out, but that it's following rules that comes together in something that is coordinated. So that, that might be up there, and certainly that would go some way to helping your point. But also it might point towards the value of us moving towards a single upper ontology. Now that's questionable. It's not a definite thing, but at the moment we de facto have multiple ontologies, and it might make sense over a period of time to move towards having a smaller number. So just to throw it out there.
Okay, we have like 1 minute left, so we're not going to go into...
thinking about the indefinite thing at the top of my meta-ontology.
a discussion about meta-ontologies at the moment.
Yeah, it's fantastic.
So just to wrap up the panel, what I'd really like from each of you is a very short, tweetable, one thing that you would like the room to take away from the discussion or from your vision of what shared engineering data can bring to us. Jim, do you want to go first?
Yeah. We need to share the benefits both in terms of better services, but also the economic benefits. So we need, I would suggest, a new social contract so that it is clear that we're not worsening with this approach the great imbalances that already exist in our societies.
Thank you. Helen?
Well, I think a takeaway for me would be think about your data and think about it probably differently. Think about what you've got, what you haven't got, what you could do with the data that you've got, what data you'd need to do things differently, and just to really start thinking about that.
Thank you. Mark?
I'd say it's about working together to build this necessary consensus about what goes in the commons. If we like the idea of having a commons, we need to work together to work out what goes in there. And if you've got a bright idea on it, then have a word with Mark Girolami, who is leading our common stream in the roadmap for the Centre for Digital Britain. He's here today. He might wave his hand at you. So he's the man to speak to.
And Nigel?
Well, data is part of our critical national infrastructure, and data is, and key parts of that infrastructure have to be a public good. I mean, that encapsulates the same point I think Mark was making as well, but that is the thing we have to persuade both our corporate, our C-suite, and our political class and our public class that is not just a soundbite, it's a real thing, and so it will need investment.
Thank you. And please join me in thanking our panel. Thank you very much, everyone.
Hey, thank you very much to the panel. That was a really thought-provoking discussion. We are now going to move on to a project showcase. Just as I'm introducing this, could I ask that Manit, Tom, Rushi, and Kevin come and congregate at the front so that we can do a smooth changeover? So what we wanted to do was to kind of pair up a discussion about the kind of big vision, the grand challenges for better use of engineering data with a short showcase to demonstrate some of the ways that people are already trying to work towards that vision of the future. So to give you a flavour of some of the work that's already happening across the community. So I'll introduce the speakers in a moment. Just a couple of housekeeping things. If you haven't been able to get online yet, then there are some cards on your table which have got the Wi-Fi access code. And I'm just also going to remind you that we are there's another piece of paper on the table which has got the hashtag for today and details for accessing Slido. So at the moment, there's a poll on Slido where we're asking you all to vote on where you think the key barriers are in terms of sharing data. So we'd like to get your thoughts on that. And then throughout the day, there is a kind of open topic where you can put your ideas in about how we can help to deliver this vision. And you can vote on each other's thoughts as well. So if you all vote and contribute to that, then hopefully we can check in on that at the end of the day. So those are the housekeeping items. So we've got 4 short talks now. Each of the speakers is going to talk for about 10, 12 minutes, and then I think we'll have maybe time for maybe one brief question from the audience. So to kick us off, we've got Manit Chander from HiLo.
So this works, perfect. Good morning, everyone. Firstly, thank you very much to the ODI for inviting me to talk about HiLo. We keep hearing this fact that 90% of the goods in the world are transported through sea. The one thing missing in that statement is that there are 1.6 million seafarers across the globe moving those goods to us. So can you imagine 90% of the things on the table have come from those 1.6 million seafarers. I was one of them for nearly 2 decades. So I was sailing on oil tankers. My journey with HiLo probably started about 16 years back when I met with a very bad accident on board a ship. I nearly lost my wrist. I had multiple fractures. I had my hand hanging down. I know it's a gross picture. Sorry for that. Went through series of surgeries, had a metal plate, rods, etc. My friends called me the Iron Man because till now I still set off the alarms at the airport. I don't look half as good as Robert Downey Jr., which you must have guessed by now. But then when I went back home on my vacation, I did what all sailors do. We gossip about our last captain, and we talk bad about our company. The key takeaway for me at that time, 16 years back, was that this incident, which my company called a freak incident, wasn't actually as freak enough. It had happened multiple times across different companies, across different types of ships, but nobody was sharing that information. Fast forward, there was an opportunity to share information, hence HiLo. So what is HiLo? I call HiLo a knowledge-sharing platform on steroids. What we are is we are an independent, not-for-profit organization, which is set by the industry, run by the maritime industry. It was started about 4 years back by some of the leading shipping companies in the world. We got incorporated as a company in 2018, and very thankful to Lloyd Register Foundation for the grant that we got. We are about 1 year in inception. From inception, we have about 42 companies right now, competitors, sharing data with us, which is roughly around 3,000 ships. So we are making headway. Now, the question you can ask is, why wouldn't competitors want to share this kind of data? End of the day, people are getting injured, people are dying. Well, the analogy is simple. Imagine you go to rent a car at you're going on a lovely vacation, you're going to drive 200 kilometers somewhere, and the person across the counter says, well, here is your lovely car. By the way, this has gone through these many accidents. You've got a problem with the radiator. You've got a problem with the spark plug. Everything is fixed. It's fine now, but please, here are the keys. What would you do? Needless to say, you would never rent that car. Well, that's the problem in our industry. If people share this kind of information, which is around near misses, incidents, accidents, why will the charterers like, I can't name them, but BP, Shell, Exxon, et cetera, why will they charter the vessel? Hence, nobody shares this information. So what is the problem that we are trying to solve? On the left side, the current approach is companies are analyzing only their internal data, as I mentioned. The second challenge is when they do analyze their internal data, they're looking at only frequency. And we all know that frequency is not necessarily the highest risk. And the last is, coupled with these two issues, it's a reactive approach. It's always lagging indicators. You've had a big incident, you look for the root causes, and then you go across your 50 vessels or 100 vessels fleet and you implement a campaign. And at HiLo, what we are trying to do is flip this around. We're trying to make it proactive. We're trying to get companies to share the data and then come up with a more risk-based approach. I will apologize about my next slide. Luckily, it's before lunch, so it will work. It's a little bit of an idea of what this predictive model is all about. And apologies to all the bright people. Mark, sorry for that. You know a lot about this model. I've really simplified it, but to give you a little bit of an idea of what this model is about. I'm taking a rail example because when I use an example with the maritime folks, you can imagine the amount of arguments we get into. So in the middle, you have an undesired event, which is a high impact event. So it could be a collision or a derailment of a train. And on the extreme left, you have a leading indicator. So we actually the rail operators do count this kind of information. So on the left, let's say a broken railway track is, as everyone knows, it's a track breaking. Fallen objects is twigs, trees, probably even snow. We know what happens in winters. Fallen objects, and then you have a signal jump. Trains actually jump signals in the UK. I'm not going to give you the number because you might stop traveling. Now imagine over the quarter, we measure the frequency of the number of times we have had these leading events. So there are some numbers there. These are made up numbers, by the way. And there is a way to calculate, using statistics, there is a way to calculate the probability of these leading events leading to an undesired event. As you can see, there is a percentage there. Now, let's say we have seen the number of collisions and derailment. We can find the average, we can normalize the data, and we can find the average number of fatalities that happen in that. So what does the industry do? It will look on the left side and say, well, we've had the frequency of the broken railway track is the highest, and we're going to target that. Right? Let's do the maths in terms of risk. Don't try to do the maths here. It's correct. It's been checked a couple of times. This is what happens when you have a lot of data scientists in the room. So let's say, what's the risk of a broken railway track? It should be 10% times 10 times 3. What that means is, if looking at the statistics, 10 of the broken railway tracks should have led to a collision or a derailment. And if the average is 3, your risk is 30. Risk is of 30 fatalities. It's quite straightforward. And you can do the same thing for all the other 3, for the rest of the 2 leading events. So what you see here is, if you do a frequency risk ranking, you would do 1, 2, and 3. If you do a risk-based approach, the order is reverse. Now you can say, well, these are made-up numbers. Absolutely, they are. I was here just to prove a point. But picture this. If you have about 30-odd undesired events, you have nearly 200 leading events, and if I was to then give you a frequency against each other, do we think all of us would have the same ranking? I'm sure even Stephen Hawking can't do this. Maths. So this is the concept of HiLo. I've oversimplified this, but I'm sure you get this one. I'm asked a lot of questions as, why is HiLo different? I'm sure the shipping industry has been around for centuries. What have we done differently? Well, the answer is this. We all are aware of this cause and effect tree. The entire maritime industry, and probably many other, are on the right side. What does that mean? The information that is shared publicly is the stuff that they need to report, which is compulsory after something has gone wrong. Because probably a regulatory body has asked for it, probably it's in the news, probably the insurance companies need to know because they need to pay you off. The gold dust is on the left, which is all the data that is within the companies, which they don't want to share. And hence, that makes us different. So what do? We have this predictive model. We get the data from the participating companies, which is the 40-odd companies I mentioned. We run it through the model. We provide them 2 kinds of analysis. The first analysis is a fleet analysis, which is looking at those 3,000 ships. We tell them which is the highest risk across the fleet, completely anonymized. And we tell what are the precursors or the leading events that need to worry about. They can take the actions what are needed. What we then do is take the individual company data, run it through our model, and provide them an individual company analysis. In that company analysis, we don't benchmark them, because that will drive wrong behavior. People will start messing around with the data. What we do is we provide them a risk analysis of their company in comparison with the industry. So you know the areas where they need to improve. I'm sure you want to know if we've been successful or not, or are we going to go bust? Well, no, we are not. I will not mention the database, but this is the industry's top database. We've compared ourselves against it. And we have probably got about 10% of number of ships that probably report into that system. Yet, we have 5 times more collisions reported, 3 times more groundings of incidents, 5 times lifeboat incidents, nearly 30 times mooring. You know, ships have got those big ropes. 30 times more. The mooring equipment information is being shared with us. And in terms of flooding, we have nearly 8 times more information. And the list goes on. And have we been successful? Yes, we have. Over 2018, we were able to reduce 72% of risk for the lifeboat incidents. We actually had a company, which was the most skeptic when they joined, call us last year in July and said, it works. 4 years, we have not had an incident in our lifeboats. And last quarter, you told us lifeboat is what we need to worry about, and we said, well, this doesn't work. And literally that month, they had an incident. So it does work. We reduced 65% of the risks of engine room fires and 25% on the bunker spills, which is bunker is the cargo, the oil that is carried on these ships for moving them point A to point B. So that's an environmental thing also we were able to reduce. In the end, all I want to say is that someone asked me this question a couple of weeks back, that if you were to replicate HiLo, people need to feel comfortable to share that information. Second is ease of data collection. Companies don't have time. You can keep asking them for resources, but they need to survive. So make their data collection as easy as possible. And the third is the output. How do we make the output visual? How do we make the output meaningful? And how do we make it impactful? I'll stop here. Thank you.
That was great. We've probably got time for one very brief question, if anyone has one in the audience. You can put your hand up. Okay, quick question there.
Hi, thanks. Charlie Jensen, IT. I'm really interested in the leading indicators. How hard were they to come up with, and how much thought did that require?
It was quite easy. It took us 2.5 years. Well, it was a challenge. I think the biggest challenge was standardization of data. So I think it's a problem all the industries are facing. So we started with I think Mark mentioned very nicely, the lowest, the simplest denominator. We said, okay, companies are collecting certain amount of data. It's not the big data, this is structured data. And in that, it doesn't matter. So I'll probably give you an example. Let's say a steering gear, like ships have a steering gear, right? Now, it doesn't matter whether a company calls a steering gear a near miss or an accident or an incident or an unsafe act. It doesn't matter. It's a precursor to a collision. So all we do is we collect the data from the companies through the most simplistic way. We use the favorite buzzword nowadays, AI and machine learning, in order to extract which is basically nothing but simple text search. I was just trying to sound smart here. We pull out that information, because if it's a steering gear, it's a steering gear, and we run it through the model. So it has to start, and the idea would be over a period of time, once we get these companies to get used to using the word, we actually call it leading events. Once they get used to using the word leading events, we gradually expand the standardization. I will just pick up one more point here. A lot of people see us as a technology company. And I personally feel that, yes, we are technology as a delivery, but we are more of a change management company. Because fundamentally, we are trying to make people feel comfortable to share the data. And maritime industry is, if you think banking is all you get to meet a bunch of sailors.
Thank you very much.
Thank you.
Thank you. Okay, so next we have Tom Gowland from DAFNI.
Cool, thank you. Morning, everyone. Yeah, I'm Tom from the Data and Analytics Facility for National Infrastructure. We've got some funny animations in the slides, so I'm hoping they're going to work. So DAFNI is currently 1.5 years into a 4-year funding cycle. We're based in Oxfordshire, and we're working on this platform. And before I tell you a little bit more about the platform, I'll just tell you something about the problem that we're trying to solve with DAFNI. So we've got our infrastructure modeler called Amy, and she's working on a housing model. So that housing model might predict how many houses you're going to have in certain areas of the UK in a certain year. And so to predict that sort of information, you need census data. So you've got the census data from 2011. You've got migration data, immigration data, stuff like that. And that feeds into her model to be then able to predict what happens in the years moving forward. So then we've got another, should have another model. We've got another model called Joe, and Joe's working on a energy demand model. So what that model will do is predict how much energy is required in certain areas of the UK by a certain date. Again, he's got data to go along with that, so it could be the position of power stations, the position of power lines, stuff like that. And that all feeds into his model to be able to do these predictions. But he's also missing some housing model data, so he needs to know how many houses they're going to be in 2020 in a certain area of the UK to be able to predict how much energy is going to be required. So obviously in an ideal world, these two could collaborate. Amy could share her housing model with Joe, and then he could then go forward and make his predictions about energy. But unfortunately, they don't know each other. They've never heard of each other's work, and so they're unable to collaborate in that sense. Amy's also having some problems of her own. Her model takes a long time to run, so every time she makes a change to the code base, it'll take her a couple of hours to run through that model to see what impact that change has actually had. She's also having some problems with her data set in the fact that it's getting massive, so hundreds of gigabytes in size, and she's struggling to fit it onto her home computer. So there's a couple of problems there, and DAFNI can hopefully help to address these. So DAFNI's split up into 4 main components, the first of which is the National Infrastructure Database. So this is where hopefully infrastructure modelers will be able to put their data sets and choose who they share them with. So that obviously, I think we talked about earlier, they may not want to share that with everyone because that might be sensitive information. But as far as we can, we'll be encouraging these infrastructure modelers to share their data with as many people as they feel comfortable doing so in this one sort of repository for data, national infrastructure data. And I'll come on to a bit more about that in a bit. Then we've got the National Infrastructure Cloud environment. So this is an environment where our users can make use of the high processing compute behind DAFNI to develop their models in a safe space. It should increase the speed of those models because you've got more resources available in than on your local computer. And so those models can run a lot more quickly, and you can get results out of them a lot more quickly, and so development should be a lot quicker. We've then got the NIMS, National Infrastructure Modelling Service. Now this is split into two main parts, the first of which is the National Modelling Service Catalogue. So this is, again, similar to the NID in that modelers will be able to upload their models into this catalogue and then choose who they then share those with. Again, they'll be able to set permissions on those models in terms of who they actually want to share them with. And then there's the other part to it, which is the workflow part. And this is where you'll be able to drag and drop models out of the catalogue to create a chain of models, which then, obviously, we'll see in a minute how that can be beneficial. And finally, we've got the National Infrastructure Visualization Suite. And again, visualization was something that was gone through earlier today. And this is where modelers will be able to use our GPUs and CPUs behind the scenes to do 3D renders and 2D plots of their data and get some really good visualizations out. So how does this feed back from our scenario? So we've got Amy and Joe that come back, and Amy puts her data into the NID. She puts her model into the NIMS, and Joe puts his data into the NID and puts his model into the NIMS. So now when Joe logs into DAFNI, he'll be able to see this data available to him. He'll be able to see Amy's model available to him. And so that's great for Joe. He's got the housing model that he needed to link into his model. So Joe links Amy's housing model into his energy demand model, and that creates some visualization within the National Infrastructure Visualization Suite. And so Joe's a very happy guy because he's managed to get his model linked in and get more accurate results out of his model. Amy's also getting some benefit as well because she can then start to develop her model within the NICE. So she puts her model into the NICE, she puts all that huge amount of data into the NICE. She no longer has to worry about storing that on her own computer or running it on her own computer. And it's much more quick to run through, so she's able to develop that at a much higher speed. And so Amy's very happy as well. So I've talked a little bit about the NID, but the idea is that, obviously, as soon as someone comes along and shares a data set, that will be available to as many people as they choose. Other people then log into the NID. There'll be a metadata catalog in front of all that information, which will be searchable. So then you can search for, so Joe might come along, he might search for energy, or he might search for housing. Then all the housing and energy things will pop up. They'll be able to click into the data set and then filter down even more. So you might not want the whole of the 2011 census data, you might just want a particular part of the country. You'll be able to filter that down in our system and download just the bit that you want. Obviously, as soon as we get people using the platform, the more data we're going to be able to provide, and the better the service will be, and the more it will become a central repository for national infrastructure data. So I've talked about the four main components of DAFNI, but I haven't said that that's all wrapped in the data security service. Obviously, we're interested in making this data and the models as secure as possible. Whenever these components make a call about security, they'll call out to the data security service, which will tell them who can and can't access that data. So that's a really important part for us. We want all this data to be secure. We want users to be secure in the knowledge that their data will be safe with us. So I talked a little bit about what the platform actually is, but I thought I'd talk about some examples as well. One of the things, all the things that I talked about there are part of the core platform, but in parallel to that, over the last year and a half, we've run a pilot scheme. So these consist of sort of 3 monthly pilots where modelers from the community can interact with us. We get a better sense of what our system has to provide, and they get a better sense of what DAFNI can do for them. So this is one of the pilots that we've done recently, and it's a synthetic population and estimation model. So essentially it says if you were to create X amount of jobs and Y amount of households in a certain area of the UK, how many people would flock to that area? So this should be an example of the kind of things that we're doing. And one of the main benefits that the piloteers always say they get out of the pilot is that we've made their model available to people that would otherwise never have been able to use it. Obviously, this model is very technical to be able to run. You have to download the code. You have to then work out how to run it. We provide this nice front end to be able to run a model and visualize the output. So this is a Cam-Cox corridor scenario whereby people are moving throughout the different regions of the UK, centered around that corridor. We also do another type of visualization here, which they were quite interested in doing, and it shows the actual individual flows of people throughout these different areas. So you see that I select some of the areas around the Cam-Cox corridor, and hopefully we'll see the plot as well. So that shows the flows of people throughout these different areas. And also if you hover over the bits in the middle, it shows you the actual numbers on that, which is really good. Another thing that we did was we worked with one of the urban observatories around the UK. So there's several urban observatories now, and they're focused on putting sensors around their city to measure stuff like traffic flow, people flow. So this was a project we did with Newcastle University over the course of a week. And they've got all these sensors in the city centre and around about to measure rainfall levels. And what they were interested in doing, they had these two models. One was like measuring the rainfall levels. The other one was seeing how that would propagate over time to sort of predict where floods might happen. And so we again linked those two models in our system and produced this nice visualization of the city over time as the water inundation increases. And you can also see the live CCTV image as well as you like hover over parts of the map. I think this is actually a simulation as opposed to real-time information, because I think something like this would have meant Newcastle was under like 10 meters of water or something. So it's not quite realistic, but it gives a good impression of the kind of visualization and the kind of project that we're really interested in doing. So this is my final slide. These are all the people that were sort of currently involved with DAFNI, and obviously we're hoping that list will grow and grow. One of the sectors we're looking to really get into is the utility providers sector, because there's none up there at the minute, but they're obviously really important for our national infrastructure. So that's me. Hope that's 10 minutes.
Yeah, great, thank you very much. Does anyone have a quick question for Tom? Yeah, we've got one.
Hi there.
Hi.
How do you ensure standardization and governance on different data sets coming into your platform?
Yeah, so that's an interesting question. And it's not one I can answer easily. Obviously, the platform's due to launch on the 10th of June this year, so we haven't had anyone actually put data sets on there yet themselves. We've had all the pilot data that's come on, and that's all been in either shapefile or CSV format. As I said, each piece of data has to have metadata in front of it so it can be searchable and filterable, but that's the only standard we have at the minute. So obviously I said the pilot scheme is meant to tailor the core platform so that it will be ready for people to actually use. I think as we get more and more people using the platform, that will become more and more clear. I don't know if you've ever used the government's open data website, but I'd find it a mess. I shouldn't probably say that so close to Downing Street, but yeah, I just hope that it will be better than that, basically. That's my dream.
Great. Thanks very much, Tom.
Cool. Thanks, Marit.
Okay, so our last speaker is Kevin Schlegel from Turing Institute. There's a clicker there. I'll give you a shout. 10 minutes.
Right. Yeah. So I've just recently started at the Alan Turing Institute, and I should start with I'm a mathematician. So even though I don't actually want to show you any of the math we're doing, I want you to see this talk that the project actually really is about connecting fundamental mathematical research to a very concrete real-world application, namely the human action recognition. I'll also briefly mention a few other applications. So we want to be able to tell what are people doing from video sequences either in 2D or 3D. So let me start with giving you an idea of what we're looking at. So the videos you see here have been collected by some of our collaborators from YouTube videos. They are just over a second long, and they really give you a good idea of the variety you look at and the complexity of the task. You see lots of different actions from very different view angles in very different surroundings. And you can kind of get an idea that it's really not that easy to tell what people are doing automatically from this. To illustrate how you would mathematically and technically go about doing this, I want to go back a step in time and, well, first talk about the math a bit. So the math has been developed in the mid-90s, so from a mathematical point of view, it's actually fairly recent, fairly modern math. It's been developed from the interest of understanding how complex systems evolve in time, driven by some external influence. And the crucial notion in this theory is the path signature. And it actually turns out that this element is really good in summarizing complex time-dependent data. So what we're trying to do is really combine this mathematical tool with classical machine learning or deep learning methods. So we don't want to replace anything. We really want to combine the two and have them complement each other. And the first time this has been done, you see an example there on the right-hand side. What you're seeing there is someone drawing Chinese handwritten characters on the screen of their phone. And the task then is to translate this drawing with your finger into the actual Chinese character. There's a biannual online competition, who can do this the best, and a former colleague of ours, Ben Graham at Warwick at the time, used the path signature, combined it with deep learning, and comfortably won this competition against what I'm told was very strong French competition. And by now, what you're seeing there is it's been developed into an app which has been downloaded millions of times in China, has transcribed billions and billions of characters. You wouldn't even amaze a Chinese person with this anymore because it's just part of their daily life. They consider this normal and an easy task. But yeah, under the hood, this app uses exactly the path signature combined with deep learning. So how does this relate to human actions? What you're really seeing there is a two-dimensional path being traced out as you move your finger. And we take a very similar approach for the human actions. So we don't actually want to look at the RGB video data you saw on the first slide. But what we're doing is we're putting landmarks, so the little dots you see in the picture on the left, on each image. They represent just the positions of the major joints of the human body, so you'll know where were the shoulders, where were the hips, the ankles. And then all we are looking at is these joint positions. So basically the matchstick man you see in the middle. That has some very big advantages. First of all, it's a huge reduction in dimensionality compared to the video data, because you'll have, say, something in the order of 15 to 25 joints in 2 or 3 dimensions. So you're looking at 30 to 75 dimensions as opposed to hundreds of thousands if you look at the raw video data. And the very big advantage in terms of security, privacy, is that it's completely de-identified. From the matchstick man in the middle, you cannot tell who this person was. So if you want to use the technology to monitor a crowd, detect whether someone is panicking or someone has fallen down, you won't have any privacy issues there. Or if you're thinking of monitoring elderly people in their home, you want to see if they've fallen down, struggling to get up, you would maybe struggle to get acceptance of the technology if they're actually being filmed. You don't really want to be filmed in your bedroom when you're getting dressed in the morning. But if you can convey that everything that's seen is the matchstick man in the middle, you might have much, much bigger chances to get the technology accepted. So there's 2 questions I should address when I say we use those matchstick men. The first is this actually feasible? Can we produce those stickmen from the video data? For that, we're using open source software that exists these days that can do this automatically. It'll just take an image, find humans in there, and put those landmarks on. They can do this with like 70 to 80% accuracy. None of that is our own work, but sorry, I wouldn't say the problem is understood, but it's good enough that you can actually do something with that. And I'll show you a few examples of how good it's doing and what sort of noise you can expect in a moment. The other question I should address is whether going from the RGB data to matchstick man, I'm not actually throwing away information that's crucial. So let's have a look at how these things look like. So here you see an example of a matchstick man taken from one of the videos from the first slide. And you can see there's actually quite a lot of information still left in there, and you really can tell what's happening. Anyone want to have a guess what this person's doing? And yes, that is. And here, so the red matchstick man we just had was the ground truth. Someone went away and actually painstakingly put the landmarks, the joint positions, by hand on the video. The one in blue you see here now is the automatic version. So you see there's a bit of noise around the arms, but it's still definitely good enough. You can still tell what the person is doing. And you see the top 3 scores of our system at the top, saying that with almost 94% accuracy, we also said, well, this person is playing golf. So let's just look at another example that's a little more difficult. Any guesses? So we have a person jumping, and if we look at the results, we weren't quite as sure here, 42% for jumping, but we also thought maybe it's a catch, which kind of is reasonable. So you also see the data set really includes examples that aren't quite straightforward, where you're not quite sure to really see how we can deal with those difficulties. Another example that's really quite hard to tell even for us. Anyone, any idea what this might be? So let's look at the solution. So it's actually jumping, but not really in the way we would have expected. And yeah, our system also thought maybe it's running, maybe it's climbing stairs, but we weren't really sure. Nothing there is even above 20% confidence level. One last example that will show a bit of the noise we're dealing with. So this isn't that hard to kind of tell when you see the ground truth, someone is running there. But if you look at the automatic version, from the blue matchstick man now, it's actually quite hard to tell what this person is doing, but we had almost 98% confidence this is running. So we're actually able to deal with the noise reasonably well. But also, as you've seen in the previous slides, there are definitely still bits we're getting wrong. So we generally reach about, I think, 75% accuracy on the ground truth, considering this is about 21 actions we try to classify. And using this noisy data, we can get up to 65 or 70. 70 if you use the confidence level, so the software that puts the landmarks on also tells you how confident it is that the landmarks are correct, and if you use that, you're actually getting quite close to the ground truth levels already. One last example. Any more guesses what we're having here? This is another example where it's usually quite difficult to tell for us because the video is so short. Not quite. Yeah, so again, another example, we're not quite sure, but we got the pushing with about 43% accuracy. So what are general real-world examples? You've seen the start where the whole story started, the handwriting recognition, Chinese or Arabic or any other language. Then what I've just been demonstrating was seeing what people are doing from video sequences. So the applications we're looking at the moment are, for example, you want to monitor people on escalators, see what happens before a dangerous situation arises. Are people taking their luggage down? Are they taking their children? Are they jumping around? What's happening? What can we do to make them safer? Should we put up barriers or a sign where the lift is? Another potential application would be construction sites, see if people are carrying a load in a dangerous way or any other hazards on the building site. And then other projects that are being done with the same math that I'm not directly involved in are, for example, mood data for mental health diagnostics. So you're looking at whether people are first sad and then angry, or were you first angry and then you get sad. And it turns out from just a fairly short amount of self-reported mood data, you are able to fairly accurately tell whether people have a certain mental health condition. And currently there's also some work being done in trying to do this with automatic emotion tracking from your face. So when you unlock your phone can give a score for all those emotions just from your face. And then we want to see whether this can replace the self-reported health data and similarly tell you whether you are managing your mental illness well or if you should do something differently. And similarly, you could look at progression in ALS. People there will have scans to monitor how they're progressing in their illness, but they never have them at the same time. They never have the same amount. And that's another strong property of the math we are using, that it can deal with those variations in time, frequency, and sampling frequency and amount of data points. That is everything I wanted to say today.
Does anyone have a question? Still pondering? Yeah, okay, one down here.
Excellent work, by the way, but just wanted to ask, is your work done mostly with static cameras and moving objects, or moving cameras and moving objects?
So we're looking at various sources. So we have those videos that are kind of like CCTV. We've also looked at sources like the Kinect camera that immediately gives you 3D joint positions. We've looked at motion capture that gets it really accurately. So we are trying to do the full variety, because the math behind it really doesn't care. Essentially, that's the strength. As I said, we're also using the confidence score, the software that does the landmarks automatically. That's just another dimension for us. So we don't really are restricted in whether it's 2D, 3D, 4D, any sort of data. The strength is that it's basically a point cloud evolving in time.
Okay, thank you very much.